Welcome to another problem solving session. Though I'm not sure whether this is the most useful concept for solving friction based problems or not, but I think for many people this may be a useful concept because such kind of problems I thought they usually trouble the beginners. So I'm going to solve it in any way. And the statement of the problem that is at your screen that says a block of mass m1 rests on a block of mass m2 which lies on a frictionless table. The coefficient of friction between the blocks is mu. What is the maximum horizontal force which can be applied to the blocks for them to accelerate without slipping on one another? You can see slipping is absent between the blocks. If the force is applied to block A and block 2 one by one. So here is the case, and I need to solve it. But I never did anything special in solving such kind of problems, and I don't think any special concept is required despite the definition of static friction. First, you need to read the conditions of the problem carefully, and just move with them, just go along with them. सिंपली प्रॉब्लम का स्टेटमेंट पहले पढ़ना है और उनके साथ बह जाना है, बस और कुछ नहीं करना. सो फर्स्ट केस में ये है कि द फोर्स इज अप्लाइड टू m1 ब्लॉक 1. सो आई एम गोइंग टू ड्रॉ अ पिक्चर फॉर describing the free body diagram of block m1 and a force. एक फोर्स बाहर से लगाते हैं एंड ये फोर्स फ्रिक्शन को इनवाइट करेगा टू एक्ट ऑन m1 और ये फ्रिक्शन m1 पर m2 लगाता है. दैट मीन्स m2 ने अगर एक्शन किया है तो m2 पर रिएक्शन भी होगा और बाकी के फोर्सेस वर्टिकल डायरेक्शन में हैं. m2 पर वर्टिकल डायरेक्शन में कोई फोर्स दिखाने की ज़रूरत है नहीं, m1 पर दिखाना पड़ेगा because we do need to find the friction, the maximum value of a static friction acting between m1 and m2. So मैंने नॉर्मल और वेट दिखा दिया. नाउ आई एम गोइंग टू राइट, चूँकि दोनों के दोनों ब्लॉक को मूव करना ही है क्योंकि नीचे का सरफेस ऑफ कोर्स फ्रिक्शनलेस है, तो दोनों के दोनों ब्लॉक मूव तो करेंगे ही. फोर्स लगेगा तो दोनों के दोनों ब्लॉक मूव तो करेंगे ही. सिर्फ कंडीशन ये है कि दोनों को एक दूसरे के अगेंस्ट स्लिप नहीं करना. सो मैं मान लेता हूँ कि दोनों अभी एक साथ मूव कर रहे हैं और दोनों का कंबाइंड एक्सेलरेशन ये है, कॉमन एक्सेलरेशन ये है. सो इन दिस केस आई एम गोइंग टू राइट डाउन द इक्वेशन ऑफ मोशन फॉर m1 and this will be nothing but f minus f equals m1 multiplied by a. And what about m2? m2 is here, so I can write the equation of motion of m2 like f, the friction force, is equal to m2 into a. Both blocks are moving together right now, and if I give the equations number as 1 and 2 and adding and add both the equations, then I get the value of f, and that will be simply equal to m1 plus m2 divided by m2 multiplied by f. That's all. And I remember f is the force of a static friction that is acting between m1 and m2. So theoretically f should be less than equal to mu n, the normal force acting between them, or in this case n1. So and the value of n1 is simply mg, so mu n1 simply becomes mu m1g. So in that case I came to the conclusion that the force F, the applied force from outside, should be less than equal to m1 plus m2 divided by m2 multiplied by mu m1 g, and that's my answer. I don't do anything else to do. To solve the second case in the similar manner, I don't have to do anything else except drawing the free body diagram. So I am going to draw the free body diagram of mass m1, and आई गेस वर्टिकल डायरेक्शन में मैंने एन दिखा दिया, n1 दिखाने की ज़रूरत नहीं है, सिर्फ n से हमारा काम चल जाएगा. तो n एन m1g. इस पर फ्रिक्शन के बारे में बाद में दिखाऊंगा मैं, m2 के बारे में पहले ट्राई कर दूं. तो अभी अप्लाइड फोर्स जो बाहर से अप्लाई किया है ये m2 पर लगता है. इस फोर्स को मैं कुछ f डैश मान लेता हूँ. So this will bring friction on m1 in this direction, and that is the friction force acting on m2 in this direction, and that means the friction force also acts on m1 in this direction. May I term both friction as f dash, because this is the new problem. So I think I have drawn enough free body diagram for each of them, and then I am going to write down the equation of motion for both the blocks. Suppose that I first write for m2, and this becomes f dash minus f dash equals m2a. Both are moving together, so both will have same acceleration. And for m1 I can write f dash equals m1a, and in the similar manner as we did things previously, we can find here f dash, and f dash becomes m1 plus m2 divided by m1 in that case multiplied by f dash. And in the same manner, since in this case both are moving together, so f dash here is the static friction, and f dash that f dash should be less than equal to mu n, and the value of n is again mu m1g, so mu n1 becomes simply mu m1g, and that brings us to conclusion that f dash must be equal to less than equal to m1 plus m2 divided by m1 multiplied by mu m1g, and that is our answer for the second case. So we calculated both the cases and did nothing except applying the basic idea of friction. So if you are going to solve problems like this, you have to remember the core idea of static friction and nothing else. Thank you very much for watching.